Yes.
Good afternoon. It's a pleasure to be here in FOSDEM 17. It's my first time here, and I'm from Brazil. And I apologize for the presentation is not perfect. I have lost my luggage. I'm from Brazil, and my luggage was lost during 2 days. And some hours ago, I received it with the components for the demonstration, okay, with the material for the demonstration, and so it was a little bit rushed, the presentation, and at least I'm here. I lost in the morning, in the afternoon before, but I arrived here, at least. Wow. I'm talking to you about the scientific MicroPython for microcontrollers and the IoT. Why scientific MicroPython? I'm a physicist, but I work a lot with computational physics, and I try to use IoT, microcontrollers, programming, using the formalization that is needed for sensor data. Okay, so I will put a critical view about many sensors that IoT are making available for billions of people, but this data of these sensors should be analyzed in terms of error, precision, how many digits, etc. Okay. MicroPython is a free and the open source implementation of Python 3. It's not 100% compatible. It's something like 98 to 99% compatible, because it was meant to work with tens, for example, 10 Kbytes of RAM. Okay, it's a Python 3, but very optimized. It was created by Damien P. It's a physicist also, too, coincidence. And it was created 3-4 years ago. And he created the board, the Pyboard, the first board, the language, okay? And there is a community around him. So the site of the MicroPython, there is a test drive. Sometimes it is online, really. And there are documentation, etc. There are download. There is download here for the images, the firmware. For example, for many boards, Pyboard 1, Pyboard Lite, WiPy, that I'm showing here. And well, MicroPython until 2015 had only 2 boards, 2 hardware boards, Pyboard and WiPy, WiPy with Wi-Fi. Okay, but in the beginning of last year, you had some releases like MicroPython ported for ESP8266, BBC microbit for more than 1 million children from United Kingdom. It was given for children of 11, 12 years old. And you can also buy BBC microbit. WiPy 2 with Wi-Fi and Bluetooth. LoPy, it was the first microcontroller with Wi-Fi, Bluetooth, and LoRa, and it was natively MicroPython. And the other boards, SiPy with SigFox. OpenEV, it runs MicroPython and has a camera, a little camera, optimized to machine vision. All these boards run MicroPython. These two don't run MicroPython natively. You have to install MicroPython. So firmware, for example, Pyboard, the first Pyboard, this version is a new one, but the first one was almost the same. WiPy, the second board, WiPy first. The MicroPython project for ESP8266 last year. BBC Microbit, and you can, yes, there is Python here. And you can develop without installing any software. You can use the browser to develop. It's very important for children and parents to have a simple tool to develop. WiPy 2, okay, LoPy, and OpenEV, a new version, will be released, I think, next month, and the older version. So it has a very small board, microcontroller with a camera, using MicroPython. Okay? And sorry, I didn't have time to rush. The pre-memory of these boards, boards, is between 8 Kbytes, BBC microbit, only 8 Kbytes, to almost 100 Kbytes of Pyboard. Okay, so to develop for MicroPython is different from developing to Python, because you have your memory constraint, very important. Well, about the demonstration. First, I show almost the last one. This microcontroller, this board is LoPy with LoRa. Okay, so you can have some kilometers of the communication. 20 kilobits per second, approximately, until distance some kilometers, depending on the region. BBC microbit here. It's excellent price, and it's being used for 1 million children. And this year there will be a microbit for international version released in other countries. So microbit is now an organization, not only British. Okay. And well, just to simple to remember when you are alone, not in front of a lot of people. Okay, and I will use this. For example, it's very simple to use. I recommend to use MicroPython in the interpretive mode, interactive mode. You can also make scripts, of course. And so I use a terminal using USB serial connection, okay, to enter in MicroPython on the first board. It's a new version of the first Pyboard. Okay? So this command, it's runs MicroPython, almost the last version. Okay, there is a new version in January, and it's not compiled language. Yes, it's Python. Okay. It's like a microcomputer, in reality, a microcontroller running Python almost as an operating system. So it's the dream of the Python users. Having only Python, not Linux, not Mac OS, not Windows, only Python, almost full Python. Okay, and well. Some modules are already loaded. For example, the Pyboard module has a lot of sub-modules. For example, detailed information of this board, microcontroller. You have here about 100 Kbytes, and the flash memory is something about 90 Kbytes. There are some files there, so it shows less. And yes, you have the release, the version of the Pyboard, and it's very simple to read. I'll show a sensor connected to the ADC analog to digital converter of this board. This board has some inputs with 12 bits of the analog to digital converter. And to read the ADC port is very simple. It's one line of code. Okay? Yes, I have read the board. It is oscillating because I have here infrared rangefinder of the sharp here. It can measure the distance between 10 to 150 centimeters. So I will run a script to, okay? And this, what I'd like to show that if the data is stable, the physical quantity is stable, the reading is not stable. You have a lot of noise. All the sensors have noise. All the physical quantities, I'm a physicist, all the measured physical quantities in the world have errors, uncertainties. And the IoT community is forgetting this important thing. When we are publishing sensor data, it's important to take into account this reality. Okay? So the quantity here is not stable, the distance. Okay? And I run another script to show the statistics of these readings. Okay? So the distance of my hand was 16 centimeters, 17 centimeters, with a standard deviation. Without statistical treatment, it was a huge, more than 1 centimeter, the standard deviation. With a statistical treatment, removing some peaks, some data not good, it was reduced. And now I will show. Sorry. When I increase the distance, when I increase the distance, the error is increased. For example, and I have to increase it more. So the error is increased with the distance. It's not constant. Here we import another script with uncertainty calculation. So I have imported a module. I have created adapted a module from Python to MicroPython, calculating uncertainties, errors, error propagation. Here I have to put the hand on the cycle here. So we have 70 centimeters with an error of 1 centimeter. But if the distance is increased, the error is increased. Okay? And this is done by error propagation, uncertainty propagation. It's a code, very simple. Scripts. So this code is a class, and it's possible to run in machines in MicroPython boards with free memory, small free memory. There's no problem. And this code was not available before. Here I will present another board. Remove it. Yes. Here I have a ESP8266 microcontroller configured with MicroPython, and the serial port is a little bit different. And there is another sensor connected here. It's a BME280 sensor with pressure, humidity, and temperature. All of them, they have uncertainty errors. So I'll show statistics. Oh. example before, just to show that this microcontroller has about where is the library? Sorry. It has 28 Kbytes of RAM only. Okay? I will show the reading of the sensor. Oh, yes, it's working. So we have the pressure reading. It has a lot of noise. And I run the same sensor with other configuration. Because this sensor has many modes of reading. And in this new configuration, the error is a lot smaller. So it's very important to understand the sensors. The PDF of this sensor has about 50 pages. It takes a little time, yes. So the uncertainty is just 4 instead of a very huge one before. And okay. It's a web server running on this MicroPython board, and it shows the 3 quantities, physical quantities, with errors. And you have here, you can see that the errors, for example, it's frozen. Why? It's crashed. Yeah. I have to remove it. Connect again. Let's do it. That's good. You want to ask some questions from the crowd? Okay. Here's the connection. The window before have 2 parameters, measurement parameters that you can configure the error estimation of the sensor. And the majority of people exposes the data sensor without showing the error. There is the error. It's very important. And the scientific module is available for MicroPython. The math module is available, not exactly the same for all boards. For example, this microbit is very limited. You have for Pyboard a fast Fourier transformer in assembler code available from MicroPython. It's very fast, okay? And you can compare with a supercomputer, grade 1. Some years ago, with a Pyboard that's here. Okay, it's comparable to a grade 1, calculating fast Fourier transform using MicroPython. Okay, and I participated in this project football where you use there's an IoT experiment where all the sensors will have control of errors and uncertainties. Okay, so you have the responsibility to show for the community about 10 sensors, all of them controlling the details of the measurements. Okay, and all the development using microcontrollers and Raspberry Pi is done with Python MicroPython. Okay, thank you very much. Thank you very much.